In some earlier videos, I introduced you to the way that I implemented concurrency in this application. There is another way. There's actually a couple ways. I introduced you to the use of dispatch queues with Grand Central Dispatch. There's also another mechanism called NS Operation Queue, but I chose not to use that in this example. Let's take a quick look at how I actually implemented concurrency in the app. I'm not going to look at the UI the main UI thread. That's just provided by the operating system when the app launches. But I'm using concurrency in a couple places. All of my database work flows through this content resolver class. And you can see here on the initializer that it takes two parameters, the execution queue and the completion queue. And this implements the strategy that I discussed in another video where work is performed on an execution queue and the response or result is handled on a completion queue. So if we look at this, the implementation, some of this goes beyond the scope of this video, and I'll get into in other videos, but I use a framework called bolts, and they introduce this concept of an executor. And so I declare an execution executor and a completion executor. And then down here in the implementation of the initializer, I create an executor for the execution queue and an executor for the completion queue. And then when I actually dispatch work to that, I'm just going to take a quick look at an example down here. Let's say a delete. This is a SQL delete through the content resolver. What I do here is I execute through the execution executor, and then when that completes, I return a response on the completion executor down here. And this holds true for all the for all the SQL operations. So here's an insert, and I execute the insert on the execution executor and deal with the response on the completion executor. Same for a query. Here I perform the query on the execution executor and I return the result on the completion executor. So I showed you where the initializer declares those arguments for passing in. I want to show you real quick where I provide those. So if I look at the module folder, I use a dependency injection framework for dealing with that. So let's look at the content resolver here. And this is a declaration using Typhoon, which is the dependency injection library that I'm using for this application. And you'll see here that I pass in a dispatch queue create, and I give this a name of io.NimbleNoggin.content.execution, and it's a serial queue. And then my completion queue is a similarly named queue, and it's also a serial queue. I'm also using AFNetworking for all of my networking operations, and those are all declared here in the Data Dragon folder. So if I look at the implementation here, these are remote. I have two. I have an NIO Data Dragon CDN Request Operation Manager, and this class is responsible for invoking requests to cache images from the CDN. So you'll notice here, I don't declare an execution queue, and that's because AFNetworking declares its own. All I have to do, if I care, is to provide a completion queue, and I declare that on my initializer. And all it does is sets a property, and AFNetworking will schedule work on its own background queue and then return responses on the completion queue that I provide. Same here for the API Request Manager. This class is the one I use when I invoke requests against the Riot Games Data API. And I also have an argument here in the initializer to pass a completion queue. And I simply, like in the other example, in the initializer, I set it, and AFNetworking will use that. So when I look at the declaration of that in the dependency injection declaration, here's the CDN request, and I'm actually using the shared background queue for the completion queue, and the same down here for the other, right here, the static data API request manager. I'm using the same background queue, which is multi-threaded for the completion queue.